So salt domes have a lot to do with oil, actually. So I figured I'd bring them up in this lecture. You will hear about them more because they have a number of features that form around them that make interesting features in the deep sea and the Gulf of Mexico. So we'll definitely talk about them. So introducing salt domes. A salt dome is a mound or a column of salt that has intruded upwards into the overlying sediment. They form in a sedimentary basin where a thick layer of salt is overlain by younger sediments of significant thickness. And so you have a thick layer of salt that is deposited, for instance, when a sea evaporates. And then over that, you have a large amount of sediment, a nice thick layer. And the salt will be extruded through that sediment and can push to the surface in a bubble. Salt dome bubbles can rise thousands of feet above the layer of salt from which they began growing, and so these can be quite tall features. And the growth of the dome is accomplished by the migration of the salt into the dome from the surrounding areas. And so you can see here the salt is moving from the surrounding areas into the dome itself. And it's migrating into this dome because it's compressed by the weight of the overlying sediments. So it's just kind of like oozing. After being pressed down, it's oozing up into the salt dome. Salt domes were an almost unknown geologic feature until an exploratory oil well was drilled on Spindletop Hill near Beaumont, Texas. And this was in 1900. At a depth of about 1,000 feet, the well penetrated a pressurized oil reservoir that blew the drilling tools out of the well and showered the surrounding land with crude oil until the well could be brought under control. And these are some people that had gathered to watch this spout of oil spilling out at Spindletop Hill. This was a really productive well. The initial production from the well was over 100,000 barrels of crude oil per day. And this was a greater yield than any previous well had ever produced. And so after this success, the Spindletop discovery ignited a drilling spree on similar structures across the Gulf Coast. And so they were looking essentially for mounds, for salt mounds. And some of these wells struck oil, and so geologists decided to learn more about these salt dome structures and the reasons why they were such a great source for oil. And so here's the reason why you can find oil associated with these salt domes. So as a salt dome grows, the rocks that it pushes upwards, those rocks are arched, and the upwards arch allows oil and natural gas to migrate up to form reservoirs where they're trapped there next to the salt dome. Also, the rising salt can cause faulting. So you can see there are cracks in this rock here. And these cracks in the rock allow oil and gas to flow up till the next structural trap and form little reservoirs there. And so a variety of different locations around a salt dome can form oil and natural gas reservoirs, and you can see them at a variety of depths and locations around a salt dome. So if you were to drill around a salt dome, you could drill around the top and find some reservoirs, and then most notably, you'd be able to drill along the sides of it, and all down the sides, you'd probably find some oil and natural gas reservoirs. Salt domes also have another resource that can be mined. They are sometimes overlain by rock that contains significant amounts of elemental sulfur. And some salt domes have enough sulfur in the cap rock that it can be economically recovered. And cap rock would just be the rock that's right above the salt dome. And to recover sulfur, you would drill a well down into the sulfur and then pump superheated water and air down the well and melt the sulfur. And then that sulfur is kind of like a frothy slurry. It would rise to the surface, and then you would build a well to collect that at the surface. This isn't really a cost-effective way to mine sulfur, at least not yet. So today most sulfur is produced as a byproduct from crude oil refineries. So it's easier just to take it as essentially a waste product from refining crude oil than to actually mine it. But sulfur mining does occur in some places, and in some of those places there are salt domes that sulfur is coming from. So even though it's not cost competitive in most cases, it still is a source of sulfur. We specifically want to talk about salt domes in this course because there are many salt domes in the Gulf of Mexico. So the Gulf of Mexico has a whole belt of salt domes lying beneath the surface. So this would be the continental shelf of the Gulf of Mexico. This is the Mississippi River Delta. And these salt domes, as you can see, they lie offshore essentially from the panhandle of Florida all the way throughout the coast of Texas. There are over 500 salt domes that formed as the Gulf separated from the Atlantic Ocean. There were periods where the Gulf completely dried out and filled up again and dried out and filled up again. And so salt was deposited on the bottom of the Gulf of Mexico, and sediment from the Mississippi River covered up these salt deposits. And then that's why you have so many salt domes that have been formed on the shelf. So you got a thick layer of salt and a super thick layer of sediment overlaying it. The salt domes in the Gulf are huge. They're thousands of feet tall and several miles in diameter. Here's a close-up picture of what these domes look like. You see these pits that form when the salt domes are the salt gets exposed to water and then dissolves, and then you get those salt domes kind of collapse. And so these are locations where salt domes have collapsed, but there are other locations where the salt dome is fully intact. And many of these salt domes are associated with oil and natural gas reserves, which is one of the reasons why the location offshore on the shelf of the Gulf of Mexico is so productive for oil and gas, because we have all these features that allow these super productive wells to form, or super productive reservoirs. So this is a pretty special feature of our coastline, our offshore area. In your readings, you read a lot about Avery Island when you were reading about birds and birds being hunted for feathers, and then eventually these bird sanctuaries forming, and one of which was Avery Island. And Avery Island is also interesting because it is a salt dome. So salt domes can stretch far inland in states bordering the Gulf of Mexico. That's because at various times the sea level has been pretty far inland. And as that shallow sea evaporated, salt gets deposited on what we now consider land, but was then a shallow sea. So they can stretch far inland, and Avery Island, which looks like it's somewhat inland and is the home of Tabasco sauce and a famous bird sanctuary. This is actually a salt dome that's surrounded by salt marsh. And then it's interesting to know that salt from the island is actually used to create the signature hot sauce, and so you wouldn't have Tabasco sauce without salt domes. It's actually a pretty high mound. At its highest point, it rises 163 feet above sea level. I think my house is like 11 feet above sea level, so that's pretty high. It's pretty high up there. This is a picture of Avery Island as viewed from above. You can see, even though it's not an island surrounded by water, it's surrounded by salt marsh, and so to get there you need to travel via bridges. And it's somewhat raised in like a hill. Other salt domes that are well inland, at least they're well inland today, have been used for a variety of purposes other than mining salt to make hot sauce. So these salt domes have been used to create the Strategic Petroleum Reserve. And the Strategic Petroleum Reserve is emergency crude oil that the United States stores to help weather disruptions in oil supply. And so we don't want any sort of disruption in oil supply to completely take us off the grid. We've got enough to last some time, even if we don't have a great supply. And I don't know about you, but when I used to think about the Strategic Petroleum Reserve, I would think about hundreds of thousands of barrels of oil, like stored in some warehouse in the desert. But this is not actually the case. And so when the US government decided to create the SPR in the mid-1970s, it acquired previously created salt caverns, which were evacuated salt domes, to store the first 250 million barrels of crude oil. And so they're stored underground in these caverns created from salt domes that have had all the salt mined out of them. This was the most rapid way to begin securing the emergency supply of crude oil, initially following the oil shocks of the 1970s. And so they wanted a place where they could store a lot of oil fast, and these salt domes provided an opportunity for that. And it's far safer than storage of oil in barrels on land. So there are 4 major oil storage facilities that were formed from salt domes in the Gulf Coast region of the US, and these are the 4 here, 2 sites in Texas and 2 in Louisiana. And then as the Strategic Petroleum Reserve expanded, additional caverns were created specifically for storage. But these 4 were the originals, and they were created from salt domes. And then finally, perhaps the best use of salt domes, it turns out, is as a storage area. So now people are talking about using these salt domes to store hydrogen. So there was a lot of excitement earlier this century about hydrogen as a fuel source. The lightest element on the periodic table, they're thinking that it was going to solve a number of our energy needs. Everything from portable devices to high-rises were going to be cured and fueled by hydrogen. But it turns out that hydrogen storage is a huge problem. So when you're going to be creating a large amount of hydrogen for use in energy, it's even harder to store than radioactive materials, because, it's flammable and takes up a lot of space because it's a gas. And so it turns out that salt domes are now being viewed as a possible storage site for hydrogen. Salt domes near Salt Lake City, Utah have been tapped to store hydrogen gas. This is an image of Salt Lake City, Utah, and some of the salt ponds located there. And if these locations can safely store hydrogen gas, it may enable the use of hydrogen as an energy source, because a lot of the technology has been figured out. It's mainly the storage problem that has to be solved. And so potentially with these new advances in using salt domes as storage, we will have hydrogen as an energy source in the near future. Pretty cool.